In Module 3, we're going to look at sharpening and blurring. These are things we can't do with a lookup table. We need to do them by convolution. Convolution with a mask, either a sharpening mask if we want to sharpen, or a blurring mask if we want to blur. We'll talk about the process of convolution a little later, but in this exercise today, I want to do some blurring in image J and also some subtraction. So if you open up image J and go to your files and open up rice, we find it rice.tiff, open that up and make a duplicate. And let's open the live histogram in Plugins Chapter 5, Live Histogram. This is the histogram of that image. The image itself, if we move the cursor around and look at the pixel values up here, we see that we have rice grains on a background. The background is not black, however, and is not even constant gray. It's kind of darker down here. You see those values 53, 54, and lighter up here. And that's a bit of a problem when we come to do segmentation, which is try and split the rice grains from the background. It would be much easier to do if we had a black background, an even black background. So if we took another picture with our camera and lighting, there was a problem here that gave us this uneven background. If we took another picture without the rice grain, then we'd see that uneven background and we could subtract it from this one to get a picture of the rice grains on black background. But we haven't got this other picture to subtract from this. We haven't got the variable background picture. In fact, we have to make it. So that's the first thing today. We're going to try and make a background, a variable background, that has numbers like 55 down the bottom left and numbers like 90 up the top right. We want to make that background and then subtract it from this image. In order to make the background, we'll take the image and blur it. We'll blur it so much that the rice grains will get blurred out. So here we are on process. We'll go down to filters. It should be called masks. Image J has made a mistake here. We'll read it as masks. Masks and filters are a little bit different. So we're looking down here and we're looking at Gaussian blur. We want to blur this image using convolution with a Gaussian function. The details we'll look into later. You can look up, though, in the image J documentation, look up process filters Gaussian blur and read about it a little. So we go to that and it comes up here. I've been using 50, but I think the default when you open it up will be 2. So we're going to blur this here with a Gaussian which has a sigma, like a half width of 2, and we can click the preview and see what happens. It blurs the image. Blurs the image, and as you increase the width of the Gaussian that you're using to do the blur, we try a 10, it blurs the image more and more. It hasn't completely blurred out the rice grains yet, but we keep going until it does. So we can try 30, and we may think that's blurred out and this is the background that we want. or it may be 50 that we need, or it may be something else. If we go too high, if we go to say 250, even that variable background gets blurred out, and it becomes less variable as we increase this number. So we don't want that. We don't want a uniform background. We want a variable background just big enough to subtract out from this image. Now in this image, let's cancel that. This image to begin with, this here is the histogram of the variable background. And this is the histogram of the rice. And we want to subtract this out. And we want the background to be black. So this here, we can see from up here, it has a minimum of 40, what we see from down here, and it has a maximum of about 97, 98, something like that. So the width of this here is 58. Width of this background, the variability in the background goes from 40 up to nearly 100. So there's variability there of 58 that we want to get rid of. So when we look back to this image here and do our masking, our convolution masking, our Gaussian blurring at various values, depending on the value we choose here, we'll get different widths. We want to get the right width that will subtract out the background from this image here. So the right width is 58. Okay, so that's what we're trying to get. I let you try different values of the Gaussian blur. Try 20, 30, 40, 50, 60, for example, and see what happens in each case to the width of this here, of the histogram of this. Now, it just so happens that 50 is about the right one, but try a few others. I say it's the right one because the histogram goes from 64 to 122, and that's a width of 58, and that's the width that we want. So we could take a Gaussian blur with a sigma of 50, and we'll keep it, that image, and we want to subtract this image from this image. That's not quite the whole story yet. This is the correct width, but it's not starting at the right point. This here starts at 40, and this one starts at 64 and goes up from there. So we want to pull this one down so that it starts at 40 and not 64. And we can do that by taking this image, going to process math, and subtracting 24 from every pixel value. That'll pull this down to 40 and all of the other pixels down also. So let's see what happens there when we go math and subtract 24. I've already set it there. You can see the preview. It gets darker, of course, and the histogram shifts down so that it starts with a minimum of 40 and goes to 98, which is what we want, is the background. So we'll take that. We're happy with that. We're going to subtract out this piece here, the 40 to 98 or so, by using this. In order to do a subtraction, we go not to math. That subtracts a fixed number from all the pixel values, or you can do a lot of other things too. But we want to subtract two images. We go to image calculator, and we're subtracting image rice and we're taking away rice 1. We can do various things, add, subtract, multiply, and various logic operations here, but we're going to do subtract, and we're going to create a new window, and we'll make it a 32-bit resulting window, and we'll hit OK. And when we do that, we get the result that we want. The rice grains on a black background, pretty well constant black. I mean, there's a little bit of variation, but there's not that 58 pixel variation that there was before. This is kind of black. And if we get to this point, and remember we've done quite a few things, you must look through this here again and use those operations in different places. But we've got this image here, and we'd like to make it black and white, make it binary. We do that by thresholding. So if we go, I forget where it is. If we forget where it is, remember we can go to shortcuts, macros, utilities, find commands, and type in threshold. We want to find where that is. And there's various thresholds, but it looks like image adjust is where we want to be. So we go into image adjust. There's the threshold that we want. We want that threshold applied to this image. And there it is. It's changed black and white, and we can change that threshold by moving up and down like this. If we look at the histogram, we want to actually threshold, that is, make all the pixels below the threshold black and all the pixels above it white. So these are the rice articles, and this is our variable threshold down here. We look at the histogram. We want to choose a value somewhere between those two peaks at the minimum, say, and the minimum looks like about 140. So let me move this back. 140 is not the right place. We go back here, look at this. This is not 140, this is 39. The minimum here is 30 or 38, 39. So we're going to move this here until we get 38, 39. And as we do that, we see the segmented image change. We want to get the best one that corresponds to this, we think. So if we go for that minimum, which was at 38 or 39, that should be it. And this is what we're going to take. There is a little problem you probably see in that these two rice grains are stuck together where they shouldn't be. But we can do something else, some other processing afterwards to make the break between those two. So everything else looks good. These rice grains look about the same size as the ones in the grayscale image. So we'll apply that value of threshold, and we apply it on this here, and we get it. I'm not liking this live histogram too much. We've got a black and white image here. If we look at the histogram of it, still not liking it. Sometimes there are problems in image J, and we may have to go binary, make binary. We do that and look at the live histogram again. Now I'm liking it. Now we have black and we have white, right? We want those two spikes. The black background there, so we want a spike on 0, which are all these pixels here, and a spike on 255, which are the rice grains. So that's where we want to get to. but I've shown you quite a few things on the way there. So you may need to look at this video several times.